Physics Penguin.
Welcome to Physics Penguin's Guide to Forces. This week we'll be looking at two different types of classification. The first covers all quantities in science, and the second only really applies to forces. So let's get started. First of all, vectors and scalars. A vector is a quantity that has a size, but also has a direction. The weather forecast might tell you the speed of the wind, but it probably will tell you the direction of the wind too. Phew, that's better. The temperature outside has a measurable size too, but it doesn't have a direction. Scalars have size, but no direction. So what common measured quantities are scalars and which are vectors? Let's look at some examples. How about force? So, does direction matter for forces? Ask people in a tug of war. Yes, changing direction of a force will make a big difference. Pushing a sledge has a different direction to slowing it down. So every force is a vector. Temperature? Can you have a temperature of 10 degrees north? No, that makes no sense. Temperature has to be a scalar. Energy? Does a car have different energy going north rather than going south? No, that would be weird. Energy is a scalar. Or what about distance? Well, what if you said there is an angry walrus 100 metres from your igloo? Do you know where he is? Well, not exactly. Is he over here? Or is he over there? We don't know. He could even be in a hang glider overhead, or even tunnelling below us. Scary stuff. Distance must be a scalar. What if you said that the walrus is 50 metres away to the west? We have a size, 50 metres, and a direction, so this must be a vector. But haven't we just said distance is a scalar? Well, true. If you add direction to distance, though, we call that displacement. Displacement has a size and a direction. The same thing happens with speed. Imagine if me and my cousin Percy are both on sledges travelling at the same speed. We must be staying the same distance apart, mustn't we? Well, no. What if Percy goes left and I go right? We could be getting closer and closer or further and further apart. Oh, watch out, Percy! Phew. Well, speed is just how fast you are moving, but speed plus direction is called velocity, and it's more useful for us scientists. What about when speed changes? People often talk about acceleration. Well, acceleration is always a vector. You have to know whether your change is going to increase or decrease the velocity of the moving object. This creates an interesting issue, though. What happens if a car goes around a roundabout at 20 miles an hour? Is it accelerating? Well, at first it seems unlikely. The speed is stuck at 20 miles an hour. But acceleration depends on the change in velocity. And velocity includes direction. Since direction is changing on the roundabout, the car is accelerating. Amazing. Finally, I wanted to look at contact forces and non-contact forces. You just have to know the difference. This is going to freak you out. Listen. If forces happen when something touches or hits something else, that is a contact force. Pushing the sledge needs contact forces. I can't move it with the power of my mind. Or can I? A compass needle points north, because one end of the needle feels a force pulling north and the opposite end gets pulled south. There's no contact here, though. That would be weird. So magnetism is a non-contact force. If you ever held two magnets close to each other, you can feel an attraction or repulsion without making them touch. This contact, no contact stuff is pretty easy. Now, have a go at the worksheet. The link is in the description. When you're done, unpause the video and I'll go over it for you. So, pause the video. Welcome back. Let's have a look at the answers to the sheet. Question 1 is asking you about the definitions of vectors and scalars. Scalars have a size or magnitude, but vectors have both magnitude and direction as well. So question 2 is about identifying vectors and scalars. Okay, so temperature, you can't say it's 12 degrees centigrade outside to the left. It doesn't make sense. So temperature is a scalar. Speed is trickier, but you should remember that velocity is the vector version of speed, so speed is just a scalar. We have road speed limits, not velocity limits, because doing 60 in a 30 mile an hour area is dangerous, whatever direction you're going in. Force is a vector, because forces always push or pull in some direction or other. Time's an interesting one. You could argue that time does have a direction, it goes forward. But we seem trapped in the forward flow of time, so it's a scalar to us. There's no time travel at GCSE, you have to wait for A-level. Finally, on question 2, we had acceleration. That is always a vector. Question 3 is asking about a moving object changing direction and asks if it accelerates. Well, it accelerates if velocity changes. Velocity is speed and direction combined, so changing direction is changing velocity. In this case, the sledge is accelerating. Question 4 is your old classic tug of war. How did you do on this? Well, it's just maths. We've got 2,000 newtons to the left and 3,000 newtons to the right, and they're both applied to the rope. It's just like taking 2,000 steps to the left and then 3,000 steps to the right. Like a really dull version of doing the time warp. You will end up 1,000 steps right of where you started. So for forces, we will get 1,000 newtons to the right. If the forces were pulling in the same direction, we could just add them up. Question 5 defines contact and non-contact forces. Contact forces occur when an object passes on a force by touching or colliding with another object. Non-contact forces occur when the force is felt at a distance. Question 6 is the last one and just wants you to look at 4 forces and say whether they are contact or non-contact. Well, friction occurs when a moving object is slowed by collisions with air or water or something or a rough surface. This always involves some kind of contact. Gravity is easy. If you step off a diving board, the earth pulls you down, but you are clearly not touching it. Gravity is a non-contact force. Magnetism also works at a distance, although that distance is a lot shorter than gravity. So magnetism is clearly also a non-contact force. Finally, the person pushing something can only do that by touching the object. So that is a contact force. Well, that's it for Physics Penguin this week. Well done for working through this stuff. If you want to be notified of the next video in the series, please subscribe to the channel. Anyway, ta-ta for now.
Physics Penguin.